we're going to start looking at using this for hypothesis testing, and specifically why correlations might be really important in helping us collect vital data within a reasonable framework, shaped by the reality of situations and how we can and can't collect data and timeliness. So, for example, in a hypothesis testing here, we might want to ideally directly measure a variable, but what if that's not really feasible? So here we're looking at, for example, they're trying to assess species health through tracking weight changes. And this is particularly important as we're having rapid shifts in our environment and we're having different changes in temperature, in terms of plankton and other things like this. So here's where we have a problem. We want to be tracking our species health. However, is it reasonable to be going around and actually measuring each and every single animal within a particular population group, especially if we want to collect measurements, say, every 6 months or even a shorter amount of time? So, it's time and cost prohibitive to measure every single seal for this example. It's also incredibly disruptive for the animals. So having somebody come on to their space and measure all of them would actually be so stressful that many of them may start eating or other change their dietary habits after that. So very disruptive events can throw off eating habits for any species. So if we're looking at that, one of possible solutions for getting data that we need that is both timely, cost effective, and also best for the animals is to use photographs. So the question is, can we actually use the overhead width of a seal measured from a photograph as an accurate estimate for the weights of the seals themselves? If this winds up to be a feasible relationship, this makes it a lot easier for us to collect a lot of data really rapidly. But we need to make sure that there's a decent relationship to make sure that our accuracy is. So here we're going to look at a practice problem with some data from exactly this kind of situation. So we're looking at practice problem number 21 on page 500. So we've been given a significance level of 0.05, and we're looking here, we have our overhead width in centimeters of the seals pulled from a photograph, and then we also have the weights for those same seals. So individuals went in and first did the photographs, then came in, got the exact same seals, and then actually weighed them. So we're going to use this information for making an estimate about how effective this technique would be to apply to others. So here we go. We've got to be going through our steps, and by now these steps should be incredibly familiar for you when you're getting ready to set up doing a hypothesis test. So the first thing we've got, of course, is checking requirements. What are the requirements for conducting a correlation analysis? What do I have to have in my data? Well, I have to have it's a simple random sample. There has to be no missing data. That means for every seal that I have a width for, I have to have a corresponding weight. There can't be any outliers, and it's got to be a relatively linear relationship. So let's go and take a look real quick at scatter plot for that. To get a scatter plot, you're going to go to Graph, Scatter Plot, and actually before you do this, of course, you've got to make sure you've got your variables entered in. So go through, open up your Stats Crunch, enter in your X's and label them as being the width, and enter in the Y variable and label it as being weight, and enter in that data, and then go through on Stats Crunch and open up Graph, Scatter Plot. You're going to assign the overhead width to variable X and assign the weight to variable Y. So pause this video here, go through and take all of those steps, and then when you've completed those, turn the video back on and we'll move on to the next step together. Okay, you should have got a scatter plot that looks pretty much just like this. So as we can see here, we don't have any really strange outliers, and it's looking like we got a roughly linear relationship. So we went back and looking at our particular requirements going forward, we can see yes, we meet all of our requirements and we are ready to move forward with our data. So the step is, of course, going through and we've got to specify our claims. Now, once again, we've got to step back and think about what would be the product if this statement was true. So, if the weights of the seals can be determined by overhead photography, and that's what we're looking at. Remember, we're setting our hypotheses here in terms of R, because we're doing a correlation. We have to think about if the overhead seal width does predict the weight, and we're expecting it to be a linear correlation or no correlation. If there's no correlation at all, that value would be represented by a straight line or a 0. Okay, so a 0 means no correlation at all. There's no relationship between these two different variables. A perfect correlation of exactly matching is a 1. Okay, so if we're going to be setting up our hypotheses here, if in fact our alternative that we feel that yeah, we can use the photography to determine the weights of the seals, then that means that we're going to be saying that the correlation is going to be some value other than 0. We don't know yet if whether it's going to be a positive relationship or a negative relationship, but we do know it's a value that won't be equal. So that's what we're going to set our symbolic claim for that must be true when the original claim is false. And remember, this language is a little bit deceiving because you're actually really easier to use the language in the problem to answer the second step and then go back and set your null. So, and then going back up and setting our null hypothesis, if there's no relationship, we would expect to see 0. And when we put these in terms of our hypotheses formula, this is what we get. So we have our null here, our HO is R equals 0. No relationship whatsoever. Okay, that is the starting point because that would be saying there's nothing happening here. However, we're proposing an alternative possibility, thus our alternative hypothesis, or H1, which is that nope, R is not equal to 0. It's either going to be a value that's going to be more than 0, no, positive value higher than 0, or a negative value. Okay, so now we've got our specific hypotheses, and once again we're going to identify our alpha. Okay, and here we've got our alpha is going to be 0.05, so we have that. And now we're moving into our next step. Now we're going to start with the critical value method. And for the critical value method, the first thing we're going to calculate, remember we have to calculate our R obtained for our test statistic, and for that we're going to use StatsCrunch. Okay, you can go through and use the manual formula if you want to, but you don't have to. You can use the StatsCrunch. So if we go to StatsCrunch, you're going to go into Stats, go to Regression, and then go to Simple Linear, because that's the type of formula we're solving here. And once you have that, you should get a dialog box like this, where again you're setting your X variable as width, your Y variable is weight. Notice when we're setting the hypothesis testing, since that's what we're doing, we're setting our intercepted equal to 0 because that's our null. Okay, so notice how that corresponds with our null hypothesis. And notice how our alternative, here they have HA instead of H1, how our alternative hypothesis is going to be not equal to 0. So check and make sure when you set these that the values for our hypothesis test are matching those that we have set for our null and our alternative hypothesis. Once we have that, we're going to hit compute. And you should get an output that looks something like this. So when we're looking at this, what is going to be my R obtained from this output? Here is my StatsCrunch output. What is my R obtained value here? It was going to be 0.948. Okay, so that I'm going to bring over, put that back in. So I've got my R obtained is 0.948. Now what's the next step I need to do? I need to find out what my R critical value is. So we're going to go locate our R critical value in our correlation table. What do I need to know to find my R critical value? Well, I need to know what my N is going to be, and I need to know my alpha. So what is my N here? What is my sample size? And what is my alpha? Well, my N is going to be equal to 6, and my alpha, as we can see, is 0.05. So pause the video here and go look at your Pearson correlation table and locate your R critical value for this particular problem. So with an N of 6 and an alpha of 0.05, what would be the R critical value? Pause the video here and get that information yourself, and then when you come back, turn the video on and we'll proceed from there together. You should have got an R critical value of 0.811. All right, now the next step, now I've got my R obtained and my R critical value, so I'm going to need to go through and graph them out. Now, be careful with the graphing here. Remember with correlations, we're going to plot our R critical value as always plus or minus. Okay, so we looked at this before, but just as a reminder, it's going to be the rejection regions are going to be tails outside from both the plus and the minus. So when we're looking at this, I'm going to go ahead and when we graph this out, I'm going to be marking my R critical value as both a positive and a negative. And those rejection regions are going to be to the edges, moving out towards the tails of that particular distribution. So if we go through and we do this and we plot our values out and we get we plot out our R critical values and then we put in our R obtained, what do we find? So is our test statistic, our R obtained, within the rejection regions on either side of the tails, or is it in fact within the main body of it between those two critical values? So if it's in the rejection regions, then we're going to reject our null. If it's within the main body of that distribution, then we fail to reject the null. So take a few moments and sketch these values out real quick, do a distribution graph real quick like we've been doing all semester long, and do your interpretation. So pause the video while you do that, and then once you've got your interpretation, turn the video back on and let's check it together. Okay, you should have got that we reject the null because indeed your R obtained is falling in the rejection regions of one of the tails. So now that we've rejected our null, we're coming back to the part where we need to restate our decision in non-technical terms to address the original claim. So the original claim is, or question is, can weights of seals be determined by overhead photography? And since we've rejected the null, which would say they can't be, this leaves us with a statement that there is sufficient evidence in this sample to support the method of inferring weights of seals from overhead photography. That is what we know from this. We, of course, probably would want to be doing some more samples. We'd want to pay attention, for example, if we were looking at different species of seals, that of course could be really different because that can make a big difference in terms of how their weight, how their overhead width is related to their overall body weight. That could possibly vary between species. So we'd want to be doing more studies with that, get a larger sample size, and we'd want to check and make sure we were being careful about different types of seals. So we don't want to overgeneralize from one species of seal to all species. So that concludes this particular PowerPoint and going through and doing a hypothesis testing with the correlation analysis. You have one more left doing this where we're going to work with a larger data set and again go through and do the various steps of, oh, my mistake. We've got one more thing to do. Here we go. We're going to do the p-value. So when we're looking at our p-value with StatsCrunch, we've already calculated that out, so we already have our R obtained. What is our p-value? Well, our p-value here is going to be 0.0039. So we're going to come back over and put that in as our p-value. And then compare that. Remember, we're going to compare that to our alpha. So if we plug these values in, we get 0.0039 is less than or equal to 0.05. Is this a true statement? If it's a true statement, we reject the null. If it's not a true statement, then we fail to reject the null. Well, this is a true statement, so we do reject the null hypothesis. And again, we would go back and do the wording for the interpretation the same as we had done for the critical value approach. Okay, this does conclude this particular PowerPoint and working through the process. As I said, there is one more that will be set up that will be having you go through and doing working with a larger data set and doing the similar steps and looking at a hypothesis testing with some correlational data.